Oh, hello there. Welcome to our video. In this video, we're going to help you with the following. Hope you enjoy.
So, this is how you do right triangle trig. More than likely, you're going to use it to find a side. So, what you want to do is identify which one of these you're going to use. And you pick one of these based on what you have, opposite, hypotenuse, adjacent. So, you do that by using the angle that you have. So, for example, this angle, the opposite would be the one on the opposite side. The hypotenuse would be the one directly opposite from the right angle. And the adjacent would be the side that's left. So in this situation, we would use, or you could use different ones, but in this case we're going to use, if we're going to find this side, we'll use tangent, because we have opposite and adjacent. So we could do tangent of 34 degrees equals opposite over adjacent, so we have opposite over, and your adjacent is 5. So we manipulate the equation to get O by itself, so we multiply by 5. And we're left with 5 times tangent of 34 degrees equals to O. And that's how you find a side. Alright? Now for inverse, to find an angle, you do the exact same thing, except now you work backwards. So you use the side, well, for example here, right? The opposite of this one would be this one. So this is opposite now. Hypotenuse stays the same, and this is adjacent. So to find the angle, you need to have two sides. So let's say the adjacent angle is 6. Okay? So in this case, you have opposite and adjacent, so you would use tangents again. But to find the angle, you use the inverse. That's fine. The inverse tangent of theta equals 5 over 6. It's 5 over 6 because it's opposite over adjacent, which is the equation right here. Then you just switch these two. So tangent of inverse tangent of 5 over 6 should give you theta. That's it. Alright, for the law of sines, you just have to follow this equation. Sine of A over A equals sine of B over B equals sine of C over C. This can be flipped upside down and it means the same thing, as long as both sides are the same when they're upside down. So you put this in use in a triangle, for example, like this. When you have an angle such as 42 degrees and its side, which is 5, and B with an angle of 39 degrees with no side. So all you have to do is just plug it into the equation. So sine of A, so sine of 42 degrees over its side, which is 5, which equals to B sine of 39 over the unknown, which is just B. And to solve, you just crisscross multiply. So this times that, and that times that. So you get sine of 42 equals to 5 times sine of 39. So, and this is times b. So that. So you want to get b by itself, so you simply divide by sine of 42. This cancels out, and you just divide this by sine of 42. So you end up with b equals 5 times sine of 39 degrees divided by sine of 42. That's it.
Alright, this is the law of cosines, and it can be applied where the law of sines cannot. For example, say you have a triangle with angle 113 at A, and on side B you have 6, and on side C you have, say, 7. Now from this triangle you can see that you cannot have any ratios because, say, side A, you don't have it, on angle B you don't, so this is where the law of sines fails, and this is where the law of cosines can be applied. Now you have options here. You have a multitude of equations, and for this example we're going to find side A, and you're going to apply this equation. You have side B, you have side C, and you also have angle A. So we're just going to work down here and input the values. A, you're trying to find, it is your unknown. B is 6 squared plus 7 squared minus 2. B, which is 6, and C, which is 7, times the cosine of your given angle. Now you're going to square root both sides, and that cancels the square out. And you're going to input that onto your calculator to get A. Now for example 2, there may also be times where they will not give you an angle. So say side C is 7 again, side B is 6, and now side A, your angle is unknown. We're going to make that 8. Now you're going to look upon the equations you have and see the variables that you do and don't know. If we're trying to find angle A, then you're going to use this equation. So you're going to get cosine of A, your unknown, is equal to side B squared, which is 6 squared, plus side A squared, minus A squared, which would be 8. Or actually, side C is going to be squared. It'll be your second one, 7. And then minus A, which is 8 squared, over 2 times 6 times side A, which is 8. And now we're going to multiply this on both sides. And the cosines cancel out. And you will apply this to your calculator and get angle A.
Okay, this is Aaron's formula. There's actually two parts of it. There's the S times S minus A times S minus B times S minus C. And to find S is A plus B plus C divided by 2. A quick example would be this one right here. To find your A, you just get the opposite, which is 6. And then the opposite of B, which is 10. And then the opposite of C, which is 8. Then you get all of that divided by 2. 6 plus 10 plus 8 will be 22. Divided by 2. And that will give you 11. And that will be your answer. That will be a quick example to get that one. The second part is side angle side, and to find side angle side is A times B times sine of C and divided by 2. A quick example will be that one right here. Your A is 7, your B is 10, and your sine is 44. And then divided by 2. Plug that into your calculator, and you'll have your answer, and your answer will be 48.1. Oh, sorry, my bad. Point 6. And that would be Heron's formula.
Alright, I will be presenting the unit circle. So, you already have the degrees set out for you. One way I personally like to memorize this is that the first angle that we have is 30 degrees from here, and from this angle to this angle is 15. And 15 on this one to this one. And then you have your 30 degrees completing your 90-degree angle on this quadrant. Now you'd like to do the same thing on this quadrant, just like you started with 30 degrees here. You'd like to do that, 30, and then 15. And then you have another 15 right here. And then to finish with 30 degrees over here. And you do that for the rest of the quadrants. Now for the radians, at 0 degrees, your radian is going to be 0 pi. Your radian at 30 degrees is going to be pi over 6. Now the angles closest to this axis right here, they're all going to start with pi over 6. So we're going to go ahead and put that. This one's closest to this axis, so pi over 6. We're going to fill out the numerator later. And this is going to be pi over 6 as well. The middle angles, they're going to be pi over 4. So we're going to fill that out. Middle, pi over 4, pi over 4. The angles closest to this degree are going to be pi over 3. So it's going to be these two corresponding angles, pi over 3. Now all we have to do is fill out the numerators respectively. For this quadrant, it's already completed. Oh, we have the 90 degree. That's going to be pi over 2, because pi is 180 degrees, so half of that is 90. So we're just going to make this pi already. Now for this quadrant, it's a little tricky. This quadrant, it's a little tricky on the numerator. But all you have to really remember is that on the numerator, it's always going to be one value less of the denominator. So 1 less from 3 is 2. 1 less from 4 is 3. 1 less from 6 is 5. And on this quadrant, it's going to be opposite. The numerator is going to be one value above whatever is on the denominator, which is 7. 1 above 4 is 5. 1 above 3 is 4. And down here, you're also going to have pi over 2, but it's going to be 1 above. So 3 pi over 2. This one is the most difficult as far as the numerator goes, but one quick way to know what it is you get the corresponding angle on the other side. So you trace it down here, and you're going to get 2 plus 3, it's going to be 5. So this is going to be 5. And then for pi over 4, get the corresponding angle and trace it down, and then 3 pi over 4, and then you add those together and you're going to get a 7. 7. And then for this one, it's going to be 5 plus 6, and that will be 11. And then to complete out the circle, it's going to be 2 pi. Now we're going to move on to the coordinates. Starting at 0 degrees, you have 1 and 0. And then here, you have the square root of 3 over 2 and 1 over 2. And then in the middle, for the 45 degree, you're going to have square root of 2 over 2, square root of 2 over 2. And then right here, you're going to have the same as this, but it's going to be flipped. So your first coordinate is going to be 1 over 2, and square root of 3 over 2. And up here, you're going to have 0 and 1. Now, if you know this first quadrant, then you basically know the rest. And here's a quick way. Right here, the coordinates are going to be the same on this side. If you see the symmetry, and you take this axis, and then you fold it, this angle corresponds with this angle, except your first coordinate is going to be negative now. Well, actually, that would be your second coordinate, would be negative. Actually, your first. Now, on this side, you're going to take the corresponding angle, and it's going to be square root of 2 over 2. Except your first coordinate is going to be negative. On this side, you take these coordinates right here, place them over here, but it's going to be negative. On this side, it's still going to be the same method. It's just going to be 1 and 0, except the 1 is going to be negative. On this quadrant, it's going to be the same as this one. This time your line of symmetry is going to be here. And now this angle corresponds with this one. And they're going to take the same coordinates down here and put it here. And now both coordinates are going to be negative. This one is actually really opposite to this quadrant, because the coordinates on here are positive and these are all negative. Now back to this one on the 225 degrees, corresponding angle for this one is going to be the 135. So you're going to put these coordinates down here now. Square root of 2 over 2 over negative square root of 2 over 2, where you're going to make them negative now. And for this angle, 240 corresponds with 120. Put it down, same method. And now for this quadrant, your line of symmetry is going to go back to this axis, and now these are going to be corresponding. But the difference with the coordinates is now the first coordinate is going to stay positive, while the second one is going to be negative. So now 300 corresponds with 240. So you're going to put 1 over 2 over square root of 3 over 2, and now your second coordinate is going to be negative. And you do that with the rest of the angles. and that would complete your unit circle.
Now to graphing a horizontal shift with sine. So for that, we'll use the example of sine of theta minus pi over 2. Now, the number that you have here is going to be what determines it, whether if it's a positive or a negative horizontal shift. For this, what you want to do first is write down your first or your main points, which are 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Next, you want to look back at your equation. See how we have a negative pi over 2? For that, you're going to turn it around. So you're going to make it plus pi over 2. So you go back to your main points, and you're going to add pi over 2 to each one. Once you are done adding them, you should get something like this. Pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Now these are going to become your new points. So what you're going to want to do is plug them in. Have pi over 2 on your first one, pi on the second, 3 pi over 2, 2 pi, and 5 pi over 2. Now, since this is a sine equation, you're going to do the same thing as on the parent function. So it's going to start on your first point, which in this case is pi over 2. So it's going to start there. It's going to start rising all the way to the top. Turns back down at pi. Does the same thing. Goes back up. And ends at 5 pi over 2. And that is how you get your horizontal shift with sine. Now for a vertical shift. Vertical shifts are honestly one of the simpler things to do when it comes to shifting within the graphing of sine and cosine. Now here you have your parent function, which is pretty simple. It goes up and down. Now for this, we will use the equation 2 sine of theta. Now the number in front of sine is the one that determines the vertical shift. So here we have a positive 2. So this means that the vertical shift will increase by 2. Now this is a graph where we're going to plug in this equation. So as I said, it's an increase of 2. So you're going to look at your top and bottom numbers, which in this case are -1 and 1. So what you're going to do, let's start off with -1, which is, let's say, the most difficult. So with -1, you're going to add 2. So -1 plus 2 equals 1. So it's going to be your bottom. Now let's look at the top one, which is 1. 1 plus 2 is 3. So that now becomes your top one. So what do? You do the same thing with as the parent function. You start at 0 pi, go up, and back down. And of course, the normal graph that you guys will make is a little bit longer, but just for this example, I made it a little bit shorter. Now for cosine, however, it will literally be the same thing, except you would start from the top, go down, and back up. Just how you would do any other cosine graph. That'd be it. Alright, now to graphing cosecant, secant, and cotangent. For this one, let's start off with cosecant. Now the parent function looks a little bit like this. Goes down and it crosses this point right here. Once it hits to pi over 2, it goes back up to pi. And you might think, what happens next? Now it actually moves to the bottom section. So we're going to start right here at pi, and then it's going to start going up again, crossing this point right here. So it's going to go back up and then back down, and then after that it's going to start rotating back and forth. Now to graphing secant. So it's very similar as cosecant. However, this one, instead of starting from the top, and start at 1. So you're going to start it, go up to pi over 2, and that's where it stops, and then it comes back down to the negative side. So for that, we're going to start at -3,
pi over 2 right here. Go back to pi, remember this line. Once it hits pi, it goes back down to 3 pi over 2. And then again, it's going to rotate back to the top. Lastly, we have cotangent. Now for this one, it's actually quite simple. What you're going to want to do, of course, is you're going to start at the top, at 1. So you're going to do this, go back down to pi over 2. Once it hits that point, it's going to keep on going downwards, except it's going to go like that. Now once you're done with that, you move to the next section, which now it starts at 1 pi at the top. So it starts right here. Same thing, it goes down to 3 pi over 2, crosses it, and then continues to go down, and then it just repeats. So yeah, that's how to graph cosecant, secant, and cotangent.
Well, this is the trig functions. You get this, well, all of these by manipulating them. An example of this would be this one right here. For example, this one would equal sine squared, and cosecant is 1 over sine. We will put this one over 1. It would equal sine squared over sine. They will cancel out, and it would equal sine. That'll be your answer. That's it for this video. Hopefully this helped you out to understand trigonometry better. Have a good day.